Welcome to my No BS gear review channel. Today on the cutting board is Vosteed Porcupine, a knife with a top liner button operated lock, or as I call it, smock lock, after its designer Kevin Smock, whose lock appeared for the first time on appropriately called Spyderco Smock. With its compact size and cool ergonomic features, this knife is firmly positioned in a small EDC pocket folder category. As you just saw, the knife is perfectly comfortable in every possible grip, and it has jimpings on both spines of the handle, in the front and the back, in the finger choil, on the back of the blade, and even on the front of the blade. It is covered in jimpings, just like Porcupine is covered with needles, but they're not as sharp and quite comfortable in my perfectly common medium to large size hand. Tonight, this knife is getting objectively evaluated on my EDCircle. Just because this knife is on the smaller side doesn't mean it will not undergo the same exact evaluation as everything else on my channel. Blade being the essence of any knife, we start there. The tip looks decent. There's a little bit too much stropping, as you can see right here. And because of that, they managed to strop the very point on the tip off. So I wish they were doing it a little less aggressively. A small amount of stropping is always welcome on the factory edge. And actually, the rest of the edge looks very decent. And the secondary bevel is of the same width on both sides, indicating symmetrical sharpening angle, all the way to the tip, which looks actually crispier on this side. Let's look at the sharpening choil, where it intersects with the primary grind plunge and the secondary bevel. Well executed, there's no overlap between these three surfaces, meaning your sharpening will be easy and you will have ability to sharpen it many times. This knife has an 85% flat grind primary bevel. Behind the edge thickness is 18 thousandths of an inch, and it's consistent along the entire length of the edge. Translation: the primary grind is almost to the top of the blade. It is thin behind the apex. Altogether translates into good slicing performance. Let's characterize this knife as a system, starting with the weight. I call cutting edge to weight ratio a penalty factor. Weight for performance. It weighs 92 grams or 3¼ ounces. Measured from the handle, the blade length is just a hair under 3 inches. It is 78 millimeters long. This knife has an excellent size finger choil for pinch grips, but by the looks of it, they did not sacrifice the cutting edge length as compared to the overall blade length, with cutting edge smack at 3 inches, all thanks to this pronounced belly. And so the weight penalty ratio is 0.92. This indicates a balanced design. Question is, how much of that edge can you use on a cutting board before your knuckles hit the surface? And it is 1¾ of an inch, or more than a half of the overall cutting edge length. That is excellent and definitely scores us an extra point, because this measurement tells the tale of how useful this knife is in food prep or working on the projects requiring a cutting board. Next, we'll look at the deployment of the blade. I experimented with dozens of knives and measured what felt good, comfortable, and caused a snappy deployment, and what didn't work. Bottom line, a knife has to average 1.2 pounds to 4 pounds of force to deploy the blade to feel comfortable, and that range lies between Benchmade Bug Out and Hinderer XM18. Averaging at 1.37 pounds, this knife is pretty snappy. For a pocket carry knife, inserting and extracting from pocket is pretty critical to whether or not you will choose that particular knife for your EDC. To max out functionality of a pocket knife, you will have to put it in with a single hand without pulling or tagging on your pants, and extract it with a single hand without your fingers, thumbs slipping off the handle. At 128 thousandths of an inch, this webbing strap emulates the edge of the pocket quite well, and I found that a good pocket clip will give you less than 3 pounds in the insertion direction and less than 4 pounds in the extraction direction. Why do you need more on the extraction? Simply so that you don't lose it if you, say, fell down, tripped, or what have you. This knife is equipped with a wire pocket clip similar to, say, Spyderco knives, and it's a little bit sluggish on the extraction, but no points will be subtracted because it tends to stay in a pocket even as I try to shake it out with some vigor. I will test sharpness next, but first here's a little slicing demonstration. This is just a regular index card I bought at Walmart. Here you go, now actual test. To measure sharpness, I will be using these loops made out of 4-pound fishing line, which is rated for breaking strength and elongation, and my trigger pull force gauge. I'll be using a 50 Newton gauge, which gives me better resolution and consistency than that other machine, but there's no correlation between the values in grams that you get here versus that other machine. Let me know in the comments how you feel about this method after you watch this segment. I love reading and responding to your comments. Couple key points here. I'm pulling with a slow, deliberate motion, trying to avoid the scan error. I'm also measuring sharpness in several different locations to avoid the other kind of error, as in picking up the sharpest or the dullest section on the knife. And because I'm using a direct pull while the other machine uses leverage push, the results are pretty far apart. They're not correlatable. As long as my measurements stay consistent within the test, I will be able to tell the difference between the apex sharpness before my patented all-in-one edge wear resistance, retention, and toughness test. That is coming in a minute, and that's my last pull, and now I'm calculating the average to be at 411 grams. And here's my less than scientific but oh so fun WART, or wear and retention test. I'm holding the gauge to the spine of the blade to make sure I don't exceed 3-4 pounds of force. It's not a torture test. This test is the very essence of plant-measured scientific approach. Who am I kidding? Of course it's a torture test. Are you nuts? Horn on blade. By the way, the blade is 14C28 and Sandvik steel, and that is currently my favorite budget steel. So expect the knife to be budget. This video is shot before the knife is released, as Vosteed kindly sent it to me pre-release. But by the time the video is up, you should be able to check it out on Amazon or on Vosteed's site. I will show you how to find it and whether or not I recommend it in the description for this video. What you're watching me do on the screen is rerun the sharpness test. I will be taking measurements along the same stretch of the edge where I was torturing it with a staghorn. I will then provide a full-up average and calculate the percent difference. 35% or less reduction in sharpness is great. If it's more, well, not so great, but look on the flip side, it will be easier to sharpen because it usually indicates somewhat softer steels. 14CR Sandvik can be taken all the way to 62 HRC, but something already tells me this is not the case here, and Vosteed erred on the side of caution, basically selecting toughness over the edge retention. Don't worry, I will test the hardness next. For now, here's the average. 728 grams or 77% edge sharpness reduction after 40 cuts on a staghorn. Checking the blade hardness, it's my favorite part of the process. But first, I have to verify that my device is in calibration. This is a leap tester. The block is certified to be at 787 points on leap scale. And as you can see, my average comes up within 2 points, which converts into adding 0.14 HRC to the average blade hardness. 90% of the time, especially in the budget or mid-price knife category, I have to prep the tang of the blade for this test by flattening it. To save time and tooling costs, manufacturers often grind the final thickness of the blade before the heat treat. As the steel undergoes metamorphosis of heat treat, it can shrink dimensionally due to molecules rearranging into more and more efficient structures. causing this wide open large area of the tang of the blade to shrink almost imperceptibly, but enough to cause air pockets between the blade and the block. And that leads to artificially low results. Adding incompressible gel takes care of whatever air pockets left. Whoops, forgot to switch to HRC. On a standard diamond indenter tester like Rockwell, this problem doesn't exist. But there are other problems. For example, those testers could have error of plus or minus 1.5 HRC and still comply with certification process. On this tester, averaging the results preserves accuracy. 58.8 HRC is my average. Bottom line is, I would not mind using Rockwell tester, but the ones that are actually more accurate than this are $7,500 or more. If you have any idea on how I could raise that kind of money for my channel, please leave a comment. Why am I spending that much time on a budget knife? To me, budget doesn't have a meaning. Any knife should be good no matter how much it costs, and oftentimes a very expensive knife can actually underperform. So I will treat them all the same way and put them all through the same series of tests in the future, so that you can choose the best knife for you in any budget category. 59.3 zero shift adjusted average for this side, 59.1 HRC overall. Well, 60 to 62 would be an ideal range for 14C, 28, and Sandvik. Clearly the manufacturer erred on the side of toughness versus edge retention, so let's check the toughness of this blade by bending the blade to 15-degree angle while the tip is secured in this hardwood block. I'm borrowing this procedure from the acceptance testing for USMC fighting utility knife, also known as K-bar, except I'm almost doubling that bend angle just because my mind is that twisted. And speaking of twisting, this is a construction durability test where I subject torsional loads on the blade and its tang to see if it will hold up to some serious twisting moment. Yeah, a little play opened up in a side-to-side direction. I don't detect any play at all in the vertical direction. Later I will check out if there are any permanent deformations to the blade or the mechanism of the knife. For now, I just want to see if I can tune that side-to-side play out. It's a captured pivot hardware, so I only need one driver tip. I'm using Workpro driver, which will be linked in the description. It covers pretty much all your knife tuning needs. I recommend buying two just in case you run into a knife that doesn't have captured pivot hardware. And you can see me tightening it a little too tight and then loosening it while holding the button until it falls, and then tightening like 1/32 of the turn again. Here you go. Yep, just a hair tighter. I like to have no side-to-side play because it only propagates over time, which sort of decrease the usability functionality of the knife because the opening will be too sluggish and this relative motion can induce higher damage in a high-stress situation. And speaking of high stress, here's my Hype Smasher machine. This is a modified arbor press that drops this ram, which weighs 2.5 pounds. The terminal force is about 80 pounds of force, considering gravity. And what I do here, I clamp the blade in a vise that I constructed to emulate a human hand grip, because it sits on the steel rods that are rubberized with a pretty dense rubber hose. So it's similar to your hand's skeletal structure. And then I drop it. I measure the distance from the striking point to the pivot at 2¼ inches. That gives me about 12 foot-pounds of torque when it strikes. Here are all the parameters. If you need to do more calculations, be my guest. Let me know in the comments what you think. And now this is my triggering mechanism, which is my finger. I test the functionality of the lock after every strike to make sure it's still functional. It's a little bit awkward, so I'm going to change the position a little bit. New setup for me, so I'm trying to get used to it. Here you go. The blade opens and shuts. No problem, no wiggle. We can proceed. So now for the main course. You've probably seen my test before, so I'm accelerating it to 2x. And I'm dropping the blade and testing functionality after each strike. And then in the end, I will disassemble the knife and look for any kind of damage that this may induce. Let's check for function and blade play again. Still working, no side to side. Tiny little bit of the vertical or spine direction play. Good test. As I examined the blade, there is no damage to the tang of it, but clearly there's a little bit of a damage right here in this area where the tang contacts the locking spring or locking bar, right next to the detent ball. Let me line it up on the pivot hole and show you where the damage is. I hope you can see that's how it lines up in the real world. Doing my best to show you so that you can see the pivot hole as well. Here you go. On a budget knives, liners and locking mechanisms are not heat treated to more than 40 to 45 HRC, and that's why this damage resulted from my very torturous test, and draw your own conclusions. So, how did this knife score overall? Let's take a look at EDCircle. Starting with the weight and size, 2.92, 1 point for being under 4 ounces, another point for being under 3 inches, which is legal in most jurisdictions. 0.92 is the cutting edge to weight ratio. 3 points for blade geometry. Behind the edge thickness was below 25 thousandths of an inch. Secondary bevel was symmetrically ground, and almost a full flat grind corresponds well to its EDC cutter function. Pocket ability scored 3 points. There was no need to alter the pocket clip to insert it. Pocket insertion and extraction forces were within normal range. With over 70% reduction in sharpness, edge retention scored 0. Blade deployment scored 4 points. Deployment force was within normal range, and there were 3 distinct ways to deploy the blade. This knife scores only 1 point for durability. The horizontal play opened up during the twist test, and while the lock survived 4 spine strikes on a hype smasher, the lock bar sustained small damage. 14C28N is a high-quality Sandvik steel, but it was heat-treated 1 Rockwell point below its ideal range, and for a small folding pocket knife, the focus should be on edge retention rather than toughness. And so the total EDC score for this knife is 17.92. Is 17.92 a high score? Absolutely. I ran one of my worst knives through this gamut, and I got anywhere between 9 and 11 points. Anything above 10 would score average, anything above 15 will get an excellent score. Let me address the 2 big issues that we found. First, the locking bar was slightly damaged. The knife is still fully functional, the lock is still secure, and there's no way this damage prevents it from continuing to serve me in a pocket knife capacity. The reason it sustained that damage, potentially my spine strike test is a little bit excessive. But it's a measuring stick that I apply to all knives, including the ones that are designated as tactical. So I am not going to lower this standard. Therefore, this knife lost 1 point. And the biggest gorilla in the room is somewhat lackluster heat treat. A lot of designers err on the side of less warranty repairs due to snapping of the blades, so they give toughness priority over the edge retention. Also sharpening. Not everyone in the world, and these knives are sold all over the world, has a diamond-plated fixed angle sharpener. So that was also in consideration. I am not trying to give this knife excuses. If you can't live with a steel that's below 60 HRC, this is definitely not a knife for you. I think a lot of folks will find it perfectly functional. The edge retention on 14C28N normally, with a normal use, is decent. I have not played with edge geometry. I did not play with different angles, and I suspect that I could squeeze a little bit more performance in edge retention from this knife.